I'm going to be talking about model view intent. My name is Yousuf Haque. It's one of the hip, well, it's not really new, but like in the Android community, it's like fairly bubbling up. But first, I'd like to like convince you of some things first. And that's basically, you probably need a view state object. I'm not going to tell you what a view state is yet, but I'll explain to you what problems you have and why a view state would. Enough? Can everybody see the code here? It's not really like a huge room, so I feel like, okay. Anyway, so when I first started doing RX programming, this is kind of what my code looked like. I would have some sort of injected data source, whether this was from Retrofit or Realm or wherever. The idea is I would get some piece of data from somewhere, and Dagger would take care of supplying that for me. I would set up my, due diligence, disposable and whatnot to make sure I don't leak memory. And in my onAttach method, I would get a view. I would bind to the view, and I would fetch the data using just RX. I would show loading on unsubscribe, and then once the data actually came back, I would show the data or I would show an error. And this is kind of like what you learn when you say like you're going to do RX stuff. And then in onDetach, I would clear the subscription. But there's a problem. Once you start having many streams of data, you start having this going on. You have multiple sources that are mutating your view all at different times, and depending on what happens, you could be like thrown in like an inconsistent state. You have like at this point 3 different streams editing your view, and you kind of have really no guarantee that like, oh, this is what it should be, or like as opposed to like one stream just being like, oh, I'm gonna call show view now or show loading now, whereas that's not like the real state that it should be. Of course, this doesn't have to be the way. This way. You could like put effort into like making sure that doesn't happen, but that is extra effort that you have to put in to make sure that doesn't happen. One way to make sure that it doesn't happen, well, this is just what I just said. Different streams will ultimately update your view, and like unless you're careful about it, they're going to start like conflicting with each other and kind of overriding each other. One way to fix this is to have like a view state class. And a view state is kind of just a simple data class or like a value type that has properties on it, and your view is just gonna like read from this property type and render that to the screen. And what that looks, that's what's shown here on the left. On the right is how you actually get one of these things. And the idea is you would have a function that takes in your different sources of data, does some stuff, whatever that is, we'll talk about that later, but it does some voodoo magic and eventually comes up with one of these view states. And then what you can do is feed the sources of data into your function, build this observable of view states, and just tell your view to update whenever it needs to update it. And then that kind of, you're basically forced to reconcile all the different streams with each other, which would allow you to make sure that you don't have like conflicting things. And because this ends up being like a forced reconciliation, and also it pulls logic out of like what would be your view layer into like your presenter layer. You can unit test this. You can unit test that like given you can unit test that. It's fairly easy. So long story short, the view state is like a function of application state and data. If I were to go back here, like this function is a function that takes in the 3 streams and returns another stream that is all of those combined together. Your view state is a function of your application state and your data. Well, what about user input? Like, how do we handle that? Normally, the way we do that is we have functions on our presenter, and the view would call them, and the presenter would do things based on that. Well, what I want to tell you is that view state is actually not just a function of application state and data, but it's a function of application state, data, and user input. So if we were to reason about user input like that, in an ideal world, like this is what our observable would look like. We would have our data streams up top, but we'd also have streams of user input. Like if a user clicked a button, we would get like an item emitted on this user click stream. If a user typed something, we would get whatever string they typed as another element in the stream. And then we can just treat that like we would any other observable stream. We would feed that into our combine function and do our magic here that I'm conspicuously leaving out right now. But we could just treat it like we would anything else. It's not really any special case. It's just normal streams of information. But how do we actually do that? Like that's not really something that we're normally used to. We're not used to like representing user input as streams. Like we're used to setting up on-click listeners and kind of using callbacks to interact with the user. So that leads me to like my next proposition, which is like pretty much anything you would represent as a callback, you can also represent as a stream. And that's, well, RX is like really good for event modeling. Like that's kind of what it's for. You know, it's really good at modeling events, and UI inputs are like form of events. So, you know, if the shoe fits, you should, you know, kind of wear it. And actually there's a library for this. RX Binding is a library by Jake Wharton that basically wraps a whole bunch of views and widgets for you and like basically lets you create streams out of those. A good example is a button will have a .clicks method on it. Or if you're using Kotlin, it would have a .clicks extension function. If you're using Java, you'd have a static function where you pass in the button and would return an observable of like, you know, null or void or unit, basically to tell you that like there's been a click in the stream. So you can basically represent all your user input as streams, and that lets you plug them back into your presenter using Dagger. You can inject your user input streams into your Dagger module and construct your component graph and create this presenter as with user input being just other inputs into your viewState function. I'm going to go ahead and just rename some things. I'm just, you know, tabbing back and forth between. The only things I changed was I renamed this presenter to model, and I wrapped these like this like click thing in like an intent and this type thing in like a simple data class with a property. What this lets you do is if you have like more parameters that you need, you can attach them onto this type instead of just having like a raw stream of just strings or things like that. And then because like all we're really doing here is composing the stream and subscribing to it, we can actually get rid of the onAttach and onDetach functions, which are kind of like vestigial structures from presenters, and we can instead expose the view state stream to the view directly, and the view would just call get view state stream and subscribe to it itself. So we'd be like moving the responsibility of subscribing from the presenter to the view. So basically what this looks like is you're just creating a component in Dagger and grabbing the view state stream that you're supposed to be listening to and just subscribe to it. So this kind of like narrows down the stuff that needs to be going on in your presenter. Congratulations, you now know model view intent. That's basically the gist of it. The idea is user inputs are intents that are going into the system. The model is responsible for taking all the different sources of data, be that user input, you know, data, application state, what have you, whatever you need, like as long as it's represented as an observable stream, which usually it can be, it basically does its stuff, chops stuff together, massages it into a view state, and then the view can just subscribe to it and render it. That's what model view intent is. Andre Stultz is the creator of Cycle.js. He's written a whole bunch of stuff about this. I highly recommend you reading it. And he put together this really good diagram of what model view intent really is. The user does stuff and kind of sends intents into the system. The intents are sent into the model, and view state comes out and is rendered. And that kind of cycle just happens over and over again. And it's kind of like easy to like model events in your system, and it's easy to trace where things come from. You also get this like nice unidirectional data flow, but that's, you know, it's nice for other reasons, just that like, you know, you get this nice diagram. So model view intent, well, actually it's really intent model view, because that's the order that it goes in. You start from the intent, you go into the model, you go into the view, and cycle that way. I guess model view intent is just easier to, you know, say. But what he says is you can kind of represent this function as, instead of viewing it as 3 separate pieces, you can kind of abstract it into a larger piece called a dialogue. And the reason why he calls it a dialogue is because, well, it's a dialogue between the user and the application. The user doesn't really care what's inside this thing. They only know that they click buttons and type things, and this UI changes. So it's a nice parallel that, like, the dialogue is the application to the user. And I think this is important because here in this picture, what he did was he has this model view intent thing, and he says that's a dialogue. But he also says you can have these question mark things, and that's kind of to show you that you can put arbitrarily many stages into your dialogue. So like if you need to do complex transformations of data or user input before you can render it to the screen, you can do that fairly easily because it's just more operators on your RX stream. So this is like really flexible, and as long as you can somehow generate a view state, it's kind of, it can kind of fit into whatever you need it to do. So this is the piece that like we didn't really talk about. How do we really generate this view state stream? Like, it's not easy to just go from this to a view state. There's usually complexity involved in that. So I want to introduce a concept called the state reducer. State is this, a state object is just a value type that has properties on it, like, is loading, loaded, if you issued a request, it would be like request errored. It would have properties on it that tell you like what the current state of your application is. And more specifically, whatever the state of your current component is. Like in this case, the sample app that I have is like a task list application, so I have like a task list state. So if the call to like get the list of tasks failed on the state would be like, failed loading tasks and things like that. A state reducer is a function that takes one state and transforms it to another state. So let's say you had a loading state for like, the component launches, and you have like a loading state. If the call fails, I'm going to have a tasks failed state reducer, which takes a state, which takes an input of a state and returns a failed state. So this kind of explicitly defines how your state changes with each like event in your application. So state reducer takes in a state and returns another state. It's basically a way to show like how a state is mutating. Intents, or like user input, are mapped to state reducers. So let's say a user clicks a button to go load something. That intent is instead mapped to a state reducer that says, okay, well, right now the task is, right now the state is like blank. Reduce the state to now loading. So it basically tells the state how you're supposed to change to reflect the, whatever data event happened or whatever user event happened. An observable for state reducer, each like intent has its own observable of state reducers. Like for example, I might load tasks or like refresh a page, but I also might add a task. And each one of those has like an on loading state reducer, an on success, and an on error state reducer. But I merge those together. So for like loading tasks and adding a task, those state reducers would be like merged together into a single stream of state reducers. We start with an initial state and simply just apply each state reducer that comes down the stream to reflect the new state. And this is like pretty similar to React and like the way state-based mechanisms work. You start with an initial state, and you just keep on applying functions that are pure functions, and they just tell you how to go from one state to another state. There's no real like mutability going on. It's like pretty simple, and because it's a pure function, it's really easy to test. So this is kind of what it looks like in this like sample task list application that I made. First, we need a state reducer to like say, okay, we'll go load the first set of tasks. So we have a state observable of state reducer to like mutate the state such that it starts loading the tasks. Then we have all the intents. This is a stream of intents that we flat map to their corresponding state reducer. Each intent, like add task or market task completed or refresh list, has its own set of observables of state reducers. So we get the corresponding state reducer for that intent, and then we like flat map them all into one stream of state reducers. Then finally we merge the initial state one with all the ones from like the user that are coming, and if there are more ones from like for things that would change based on the internal state of the application, like let's say network goes down and you need to do something, like that would be a different state reducer that you would also merge here. And finally, you take the stream of state reducers and you call .scan on it, which is an Rx operator. And the way it works is you supply an initial state, and then you have to give it a function that takes in the old state and another function. And it basically, well, it takes an old state and anything that you want. And in my Rx world, I made it a state reducer. It could take any object. But basically, whatever you return out of this lambda, it'll pass back in next time an event emits as the old state. So what we're doing is like every time anything like happens in our application, we have the old state coming in. We have the reducer to tell us like how you go from the old state to the new state, and we just call that function with the old state and we get the new state. So it's really every single like change that's happening in your application you can like measure as far as like old state and new state goes. And you can log that and you can see incrementally exactly what changes and exactly for which event it changes. What about config changes? This is like a really annoying problem that we have to deal with on Android. Like, how do we deal with that? Especially with RX, because you have to like kind of unsubscribe from a stream on orientation change. So you usually lose whatever progress that you currently have. Well, earlier I said that you can kind of represent anything with callbacks with streams instead. So in my sample, I actually represented lifecycle events as RX streams. So I have like an event called like, well, I'm using conductor, which is like a fragment replacement. So that has like an on attach event. It has an on detach event, like on context available, on context unavailable. So each one of those are events that are being emitted down my stream, and I'm combining that with the current view state event. So the view state stream actually lives separately than my lifecycle stream. And depending on whatever the latest event in my lifecycle stream is, I either render it or don't render it. But the idea is I've now decoupled the Android lifecycle from my business logic, and now like I have this like pure thing that is kind of Android independent and more so like quote unquote pure and not Android specific. But I can still leverage, I can still like clear data when I need to, like when the view is unavailable and things like that. And just to be sure, we use take until a certain lifecycle event to make sure that we don't leak memory. Because we're like putting the view in an object and sending it down the stream, we need to make sure we clear the stream. So we take until like pre-destroy, and then once the pre-destroy event emits, then the whole stream will be torn down. What does this buy you? Because it's like really RxY, and RxY is like reactive functional, like everything's like mostly pure functions, so you can like easily test those. You don't have to create presenters, you don't have to create like a bunch of these wrapper classes that you would otherwise. Instead, you have a bunch of pure functions that you can kind of like compose together and like form more complex logic. State is very explicit, and also flow of data is really explicit. One of the largest sources of bugs in my code base is that like something changed, I don't know what changed it. But now, because everything's really explicit, and because I can trace every event back through the stream to see where it came from, like it's kind of easy to be like, oh, that changed because of this, and now I understand why. And also, something that you wouldn't really think of, but you can start like nesting these dialogues. Because the dialogue is just input and output, you can actually nest these dialogues together and build more complex hierarchies based on nesting these dialogues. Here he has this is again Andre Staltz, you should still check it out. You have mouse inputs coming here, and then this is going down this way, but this is going into another nested dialogue and coming out this way. As long as you have an input and an output, you can kind of plug them together and kind of compose them into more complex things. What does it cost you? It's really dependent on RX. If you are very uncomfortable with RX, you're going to have a hard time doing this. I'm sure you can do it, but you're going to have an easier time if you're well versed in it. There's lots of small objects being generated and thrown around because we have these like data classes of events and value types and properties. If that's not something that you can afford in whatever use case you're doing, like for example hot loops or whatever, that's something you should be aware of. But you should measure you should measure your problem before starting to say that it is a problem. And also, changes and modifications might like be generally harder to do sometimes, and that's because like you have to be more deliberate in how you do it. Like you can't just like put a line here and put a line there and your problem's solved. You usually have to be like, okay, well the data's coming from here, and then I have to mutate it here, and then I have to transfer it here. But that being said, for me, I know that because I have to code more deliberately, I end up writing fewer bugs because of it. Things that I'm basically forced to think about the things that I would otherwise forget when like just writing like an imperative code. All right, let's see some code. Okay, so I'll start with the main activity. Yeah, good call. Better? Good? Cool. So this is my main activity. I'm using conductor, so basically you get a layout and you have a container, which is just like a frame layout, and you attach another view into that layout. So that's what I'm doing here. I'm pushing this controller, which is kind of like a fragment. It kind of manages the creation of its subview. But basically I have a shell activity that pushes what is equivalent to a fragment into a container layout. And in my controller, in the init block, so controllers in conductor persist orientation changes. So you can attach things onto your controller that you want to survive orientation changes, and they will. So I do this in the init block, and because I'm using life cycles as a stream instead of callbacks, I can do this right when the object is created rather than having to wait for like on attach or on detach or whatever. All that stuff is handled through the lifecycle stream itself, so I can just do this on object creation rather than having to wait. So kind of the simplest thing to start with is we have our intent stream, which is user inputs. So first I grab the post attach events from the controller, and that basically tells me like, okay, well, whenever an event emits, I am now attached to the view hierarchy. So in the post attach event, there is a view object right here, which is the view that was just attached. So I grab the view object from the post attach event, and then now I send that down the stream. And then I get from the view, I grab the intent stream, and this is all of the intents that are supposed to be coming out of that view, and that's what this is. I should actually show you the application. So this is the application. It's a to-do list application that fails about 30% of the time. Because that's just the way it's designed. The idea is any operation that you do may or may not fail like with some frequency, and the idea is this type of architecture forces you to handle them correctly. I can also add a task here. Oh, let me continue typing. And then if I try to add a bunch of tasks, at least one of them should fail. Yeah, okay, all right. And then I could retry adding individual tasks and whatnot. I don't know about you, but I think I'd have like some amount of trouble trying to do this like with a normal stateful pattern, like having to maintain like which requests are in flight and which ones fail, especially like in a recycler view. Like you can do it, but I think it's, for me, it would be a little bit more effort. But yeah, so that's basically what you can do. You can mark tasks complete, which can also fail, marking it complete. But yeah, see, error marking task complete, and you can retry that event specifically or clear it. But yeah, so I can mark tasks complete, I can mark them incomplete, I can retry, I can add a task and whatnot. So those are like a bunch of the different intents that are coming out of my view. And that's kind of captured here. Update draft is like when the user types into the bar. The idea is we only want to show add when there's like a non-empty string in the edit text. So we have an update task intent, which grabs the edit text, grabs the text changes stream from it, maps the text changes to the actual string, creates an intent, and it kind of just sends it down this. Well, it makes it available for you to consume. And then we do that for like a bunch of different like types of operations. Like for example, the retry button has clicks, the add note button also has clicks, and we correspond that with this add note button is interesting because what we do is we grab the latest value in the text box when the user presses add. So we're actually composing streams together before we're actually sending out that intent. So we're building only valid intents of valid like values for adding a task. We create an add task intent, and at the bottom here we merge all the different types of intents together, and we take until the detach stream, and that's to tell the stream when you need to unsubscribe. So you're kind of forced to provide some sort of observable saying like, hey, when this observable emits, detach all your view streams so that we don't leak anything. So out comes an observable of task list intent, which is all the things I can do in the task list UI. From there, where'd I go? So that's where I build my intent stream. With that, I have to feed it into my dialog. So where do I get this dialog? Well, I'm using Dagger, so I have to construct a Dagger component. But usually you need an activity or a context or something to grab an instance of your application where you've hung whatever Dagger component you want. But I'm also leveraging the lifecycle events. I grab the post context available event stream, and that all that does is it grabs the general lifecycle events and it filters down to the post context available one. And I grab the first one, I grab the instance of the controller from it, and from the controller I grab the activity, or I throw, and then from the activity I grab just a bunch of more things. There's a bunch of nested stuff. And just so you guys can see, in my application I have like some components. I have a general app one, and then I have a data one, And finally, I have a UI one, and the UI component exposes task list component. You would have more components here for the individual components you have. Like, let's say there was a compose widget or whatever, you would have more components based on that. But the idea is, from the application, I can get the corresponding component that I need specifically for the task list. And then on the task list component, I have this dialog that I can grab. And that's just, kind of normal Dagger stuff. So what does this dialog do? The dialog actually is an observable transformer that transforms intents into, well, I've type aliased this task list dialog, so let me just show you the type alias. It's a function that takes in an observable of intents, and it returns an observable of task list view state. And that's kind of our contract. As long as you send in intents and you get out view states, that's kind of all you really need to know. Everything else inside is an implementation detail. But our implementation is that we're taking these intents, we are feeding it into this task list model function, which will actually build state streams, not view state streams, but state streams. State streams are like UI independent. They're just like conceptual concepts of like, oh, we are loading right now, or we are errored out right now. And then what we do is we take the state and we render it to the view state so that we have like a decoupled implementation of what it's supposed to look like versus what the actual state is. And to dig into this task list model, this corresponds to like the RX magic screen slide that I had, which is like a bunch of missing stuff. But the idea is it takes in a bunch of intents and also functions on how to build requests, like how to build an add task request, which takes in a task request and returns a completable. Or it takes in like different requests and returns completables that would go issue a call to our API or write to the database or something like that. So we have this model that takes in these streams and it outputs an observable of task list state. And the way it does that is we take each intent has its own state reducer, as I mentioned. So we have a function that basically maps on the intent and gives you the different state reducers that you need. And just to give you an idea, well, this section I've kind of went over before in my slides, but basically you combine the initial state, the intent state reducers, and form like an overall state reducer, and you run scan on each one. But just to go into detail on like add tasks, like how do we actually add a task? So the way that works is this is a higher order. This returns an observable, and the observables are functions. The emissions are functions themselves. The state reducers that I was talking about. But we get an intent about like what actual intent that we want to create, and also a builder and like how do I create a completable that will like do this add task request. And the way we do that is we have local functions here, which are a Kotlin thing. It basically lets you clean up code without making them available to the class itself. So I have a get on submit reducer, which will give me a state and tell that state how do I tell it that like there's now a pending task. So what that does is it gets a state, and if the task list state is loaded, then I copy that state and I add a pending task to it. So I'm reducing the state to now update the state to say like, hey, there's a pending task. Well, what do I do if there's a success? Well, I know that I've had to add a pending task, so what I do in this case, only if it's loaded, and that's because if it's loading or error, then I should not be able to add tasks anyway, so we just don't do anything in that case. So that was the on submit, so that's like when the request begins. If the request completes successfully, then what we do is we get our state, we copy it again, we remove the pending task from the state, and we add an incomplete task. So this is again letting you transform like, hey, there's no longer a pending task, but now it's a complete task, and it's now telling you how you update your state to reflect that. And then finally we have again on error reducer, which is how you tell the state that like this pending task like didn't add successfully. So we still remove it, but now we add a task failure instead, and then we have a bunch of reasons of like the original request, the exception, and also like the intents that you should issue if you want to retry it or clear it or things like that. And then we just return that. And finally, we assemble all those together. Add task request builder is a function that takes in a completable, a task and returns a completable. And that's just a way to abstract like actually building the request to your backend or something like that. And what we do is we grab this completable, so whatever this thing is a completable. Oh my god, completable. All right, close enough. All right, we transform it to a single, and what this does is if the completable completes, it'll now emit this one thing, and now it's now a single. So it'll emit the success reducer if it completes, so that we can transform the state to a success state. If it errors out, we instead return the on-error reducer that'll transform the state to show that adding the task failed. And then we finally transform it to an observable so that we can have a start with, which will emit a state reducer that transforms the state from like blank to that, like now we're adding this task. So depending on what happens, so we always emit like an on-submit reducer, and then depending on what happens, we might emit an on-success or on-error reducer, which will kind of tell us that like, okay, this is how you're supposed to transform the state to reflect that this action happened. And then we actually have that for all the different intents in our application. Like I won't go into detail on all of them. All this source code is available online. It's on GitHub, so you guys can check it out. And also I tried to put like comments and explanations in there. So the idea is we have a stream of state reducers coming out that tell us how the state is supposed to change over time. So everything that happens that's supposed to mutate our state is going to come down the stream and mutate the state, and you can print out the old state and the new state. So we take this state that's coming out of this model, and what we do is so that's this state stream, and what we do is we call taskless_state.render. And that's when you transform the state that you get here, taskless state, into a taskless view state. And what that does is basically it takes the state and transforms it into like, okay, well, what does that mean? If we're loading, that means that we're supposed to show a spinner, we're supposed to hide the task list, we're supposed to hide the error message, and so on and so forth. If we're errored out, then we're supposed to hide everything else and instead only show, whatnot. And so it basically does a simple pure mapping of the state to the corresponding view state that it's supposed to render. And you can get pretty nested and complicated with that if you want. And there's all this stuff here. For example, this is mapping the individual task items. So we have a list of tasks and we map those to like a completed task, which is complete true, is check enabled, mark incomplete, and so on and so forth. Like a pending task, the check is not enabled and it's not complete, and everything's disabled because you can't edit it, and so on and so forth. And then finally, in our view, in our controller, we have this view state stream that we have, and the way we do that is we simply take the intent stream and compose it with our dialog, which will transform a stream of intents into a stream of view states, and we have that for consumption. And what we do is we combine that with the latest lifecycle, and then so that we know like what state we're in when a given view state is emitted. And then in our update view request, which is just like a data type that pairs what the current lifecycle event is with the view state that we want to update it with, and then we call we actually do the update, which is right here. So we get our request, which is the lifecycle event and the view state, and only if we're post attached do we call we call view.update, and that basically just does this. We get a view state, and it's simple. You can use data binding for this if you want, and you just grab the corresponding things and you just set stuff the way you want it. You can update your adapters with new data, so on and so forth, and you are actually required to emit an observable of new intents that might be bound. I didn't have this originally, but for recycler views, you might have new items and new intents, new sources of intents after you've updated your UI. So you can now say like, okay, well, these are the new intents that have to be bound again, and you can emit that back out of your update function. So that kind of takes us back to this guy here. This is what's happening. It's just a cycle that goes in through this function and kind of has this like nice little dialogue and abstraction. So yeah, that's kind of all I have. The source code's available online, plus this is a bunch of resources that I've used in learning about this and putting together the talk. I highly recommend you check out each one of them. They're enlightening even if you don't do MVI. And yeah. Questions? Yes?
So the view state object is pretty small in this like tiny sample application, but in a larger project that I'm assuming you use this in a larger project. Doesn't that view state object just get insanely huge and complicated?
That's why we want to nest things and compose them together. So instead of having one really large one, I could have focused ones that are specific to whatever component I'm using, and I can compose those together. There's a debate that's like you should have one view state for your whole application versus like componentized view state. I don't know where I fall on that, but the idea is you would have one large one, and then you would cast them down to interfaces as you go down to smaller components.